Scientists have found that two planets smashed together, impacting, colliding each other so hard that one of them lost its atmosphere. This is according to MIT astronomer. Now, the formation of planetary system is messy. After a star has finished forming, the swirling, roiling disk of material left over from that process clumps together, forming seeds of planets. The complex gravitational environment is not a kind one, though, and these bodies jostled, colliding as they continue to grow and migrate within their systems. Now astronomers found evidence of just such a collision. It's in a young system, 95 light years from our Earth, and according to what they have found, the unusual dust around the young 23 million year old star HD 172555 is the result of a planetary impact so violent that it at least partially stripped one of the bodies of all its atmosphere. Well, of course. Now, this is the first time, astronomer Tatiana Schederman of MIT says, the first time we've detected this phenomenon of a stripped protoplanetary atmosphere in a giant impact. She said everyone is interested in observing a giant impact because we expect them to be common, but we don't have evidence in a lot of systems for it. We now have additional insight into these dynamics. Planetary formation processes is a complicated one. We have to cobble together what we know from our own formed system and others in the Milky Way galaxy that we've seen at various stages of development. When a star forms from a clump of dust and gas in a molecular cloud, a vast disk of material feeding into its growing star forms. Kindly support my Patreon account. The daily posts are 5 videos daily, and they are totally different from what I have on my YouTube channel. Thank you so much for your support and that you find all my content so interesting. You'll find the Patreon account details in the description box below. And then this disk undergoes transformation, commencing before the star has even finished forming. As specks and fragments in the disk start to cling together, first electrostatically and then as the body accumulates mass and gravitationally. And these larger clumps collide and merge, eventually gaining enough mass for a differentiated core to settle in the center and finally becoming a planet. Not every baby planet survives, though, and we think one such as Mars-sized planet that did not make it in the solar system collided with Earth to create the moon, for instance. Astronomers think that most planets don't form where they ultimately end up. Instead, they form elsewhere and migrate to their final position, and these movements would cause additional perturbations that could result in smash-ups. These collisions are thought to be quite a common occurrence during the formation of the planetary system, and they seem to play an important role in the way baby planets grow and ultimate architecture of the system. Now, HD 172555 has been thought of a bit of an oddball. The dust swirling around it has an unusual composition and grain size, an unusual amount of silica and solid silicon monoxide, and much smaller dust grains than average. It had previously been interpreted as a result of hypervelocity impact. So astronomer Schederman of MIT and her colleagues decided to take a closer look at the carbon monoxide around the star. And she said when people want to study gas in debris disks, carbon monoxide is typically the brightest and thus the easiest to find. So we looked at the carbon monoxide data for HT 172555 because it was an interesting system. And they found that there was rather a lot of carbon monoxide orbiting the star at an unusually close distance of 10 astronomical units, and at this distance the gas should have been broken down by stellar radiation, which meant an explanation was warranted. Why was this carbon monoxide still around the star? The best fit for the observations, according to the team, was a giant impact, and they were even able to narrow down when and how it happened, at least 200,000 years ago. Recent enough that the carbon monoxide would not have time to break down an Earth-sized rocky planet was smacked by a smaller body at a velocity of 10 kilometers per second. That's 22,000 miles an hour. This impact would have been so violent it blew off at least part of the rocky planet's atmosphere, and this would explain the carbon monoxide and the silica-rich dust. Shetterman said, "Of all the scenarios, it's the only one that can explain all the features of the data." She said, "In systems of this age, we expect there to be giant impacts, and we expect giant impacts to be really quite common. Time scales work out, the age works out, and the morphological compositional constraints work out. The only plausible process that could produce carbon monoxide in the system is the giant impact. The results give us tools for identifying their giant impacts have taken place. If we find large amounts of carbon monoxide where it should not be around a star, that could be a sign that things have gotten messy during the formation of a planetary system. We can then study this gas and other debris, not just to learn more about the aftermath of these types of collisions, but to understand what planets and other systems are made of, a sort of cosmic haru spicy that could lead us to the better understanding of how planets are born." This was published in Nature magazine on Science Alert. Please leave your comments. Thank you for your support.